We're always on our axis, which is tilted and spinning diagonally like that. And that's called rotation. But we're also always revolving.
What does that
And
mean?
revolving means us moving around the sun. Not rotating, because when the Earth rotates, it's just spinning around itself, like this. But when we're revolving, we're moving around the sun.
So we are
And the whole
spinning and revolving.
Yeah, we're
Ugh.
spinning diagonally and moving.
No wonder we're all crazy.
And a whole revolution, which is called when the Earth completes its revolution around the sun, takes 365 days, which is a year. And the Earth takes
what's it?
One day to make a full spin around itself.
Oh, really?
Yeah, it takes 1 day for the Earth.
Like 24 hours day?
Yeah. It takes 24 hours for the Earth to complete a rotation and 365 days for it to complete a revolution.
Revolution. That was my next question, is what is it called?
Yeah, it's called a revolution. So there's rotation and revolution.
So every year is revolutionary? Would you say that?
I guess.
Right?
Yeah.
If that's what it's...
And the other planets that are farther away from us, like Jupiter and Saturn, their revolution takes longer because they're farther away from the sun.
So why does that make it take longer?
Because
like the energy that's
when we're closer to the sun,
giving the planet?
No, because we're closer to the sun, so we're closer to it like this. So say this is Earth, this is the sun. We can just go around it like this.
Okay.
But say Jupiter is far away from the sun, so it has to go like this.
Oh.
Since we're closer,
so
we have a smaller revolution. But when it's farther away, like Jupiter, it has a much larger revolution.
Bigger diameter.
Yeah.
Okay. I see, that makes sense.
Oh, and comets have a weird way of revolving. Their orbit. Yeah. Orbit. That's another name for revolving. What they do is they have a weird oval shape. So say they start here, and this is the sun. They are super far away from the sun, and their comets are made of dust, rocks, and ice.
Okay.
And so they're formed, and they go like this. They get super close to the sun, but then get super far away. And when they get close to the sun, they start to burn up, and it forms a tail behind them.
Ah.
And
now is the dust they're made out of all the dust that's coming off the Earth? Because there's a lot of dust here.
I don't know, maybe. Meteoroids, their orbit is around the sun, but their orbit is between Mars and Jupiter. So they still go around the sun, but their orbit goes through Mars and Jupiter and the asteroid belt.
Through them? Through the planet?
No, but between them.
Between, oh, okay.
Yeah. So between Mars and Jupiter, the asteroid belt goes in between them.
Okay.
And meteoroids are when the rocks they're still in space. But a meteorite is when a meteoroid starts to fall towards the Earth's atmosphere, and it's in the atmosphere. We obviously have like oxygen and stuff, so it starts to burn up because it's falling so fast. So a meteoroid could be this big, but by the time it falls through our atmosphere and lands, it could be like this big because it has burned up so much.
And it's called a meteorite?
Mm-hmm.
Shouldn't it be called a meteor wrong? Since it hit the Earth?
No, there's meteoroids. That's when they're still in space.
I got it. It's just a joke.
Meteorites when they're falling. I mean, there's meteors when they're falling through the Earth's atmosphere, and then there are meteorites when they've landed on the Earth.
Ah.
So there's meteoroids in space, meteors falling through the atmosphere, and meteorites on the Earth.
And what's the difference between a comet and a meteor? Any of the three? Meteor, meteorite, meteoroid.
We would say a meteoroid. Well, comets are made of like ice and stuff and dust, and their orbit is different than meteors. And comets can form like icy looking blue tails around them when they get close to the sun.
Okay.
And asteroids.
What happens? Can anything hit the sun? Or is it too hot and it burns up everything?
Yeah, nothing can hit the sun, and the sun is a ball of gas. So if something was big enough and it could sustain the heat, it would pass right through it. Well, it would probably burn up by the time it gets to the core.
And how long do we have till the sun is gone?
Like
a few billion years?
Yeah. Maybe 5.6 billion years, I think. Or wait, 5.6 billion years is when another galaxy is going to come and crash into us.
Oh, cool.
Yeah, there's another galaxy coming in our path.
Can another sun be created somehow?
I don't know. There's probably multiple.
They're just really far away.
Yeah.
Is the sun also a star?
Yeah. Not a planet. It's a star. And then asteroids. Meteors and meteoroids cannot be asteroids. Because asteroids are super huge versions of meteoroids. But they're not the same. Because asteroids are very huge. And they're not small like meteoroids are.
But they're made of the same thing?
Yeah, rocks,
just the size
metals.
Difference?
It's just the size difference.
So if an asteroid hits the Earth, is it an asteroid?
No.
Why not?
Because it's just an asteroid.
But how come a meteoroid becomes a meteor and then a meteorite?
I don't know, Mommy. That's what NASA says.
I'm going to write them an email. You know I like to write my emails.
And there was one asteroid named Ceres that was actually so big, NASA decided that it was a dwarf planet.
And what does that mean?
So a dwarf planet is a planet that's very small and doesn't actually classified as a planet because of NASA's rules of what makes a planet.
What defines a planet?
Yeah. And the rules that, the one rule that dwarf planets do not follow is their own field that they have to themselves.
Okay.
Like, they can't clear the neighborhood around them. Because they don't have enough mass to, like, make asteroids, like rogue asteroids or meteors around them, stop going in the direction, and like they would able to sustain a crash from them. So say if Pluto's very far away from the sun, Jupiter's closer, but say if Pluto and Jupiter were in the same path, Jupiter could push Pluto away from it. But since Pluto is so small and doesn't have much mass, it couldn't clear other planets away from its path so they don't bump into each other.
And how is it that, is it just like the energy force field that they can do that? So
that's why Sirius, which was classified as an asteroid, then classified as a dwarf planet, is a dwarf planet.
Okay.
Because it can't clear like comets or rogue asteroids from around it.
Okay. Any more fun space facts?
There are other dwarf planets. There's one called Maki.
Is it made of fish?
No. And then Haumea, which it doesn't follow two rules. It doesn't follow the neighborhood rule, and it also doesn't follow the rule that they have to be shaped almost like a sphere.
What is it shaped like?
Haumea is shaped. It's a little bit tilted like this, and it is an oval shape.
Okay.
And it has rings.
Are they named after the people who discovered them?
I don't actually know that. But there's also Aries, and then let me see, is that all of them? Sirius, Maki, Aries. I'm pretty sure there's one more, but I can't remember the name. But Pluto is also one.
Okay. Wait, so Pluto's not a planet?
Yeah, it's a dwarf planet.
Well, how come we always have to say it when we name the planets? When we do Mavenschnup?
We don't name it.
Mercury, Venus, Earth, Neptune.
What?
Saturn.
Are you serious?
Wait, what? What did I say?
Mercury, Venus, Earth, Neptune? Mercury,
Earth, Mars.
Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune.
I just couldn't remember because we used to say My very educated mother. That's a joke.
Served us nachos.
Oh, that's
because Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune. My very educated mother just served us nachos. And when Pluto was a planet, it was my very educated mother just served us 9 pizzas.
So Pluto is not a planet anymore.
Yeah.
Dang it.
There's only 8 planets in the solar system, not 9.
Wow.
Mm-hmm. Poor Pluto got bullied by NASA.
And how many galaxies are there?
We don't know that.
No.
We can't look through the whole universe.
All right. Any concluding comments?
No.
That's it?
Yeah. Or wait, let me try to think of at least one. A day on Venus is like 248 Earth days.
Wow.
Yeah.
Wait, what? Why?
I don't know. NASA told me.
They told you personally? They called you?
Yeah.
They sent you a text message?
But I don't know why.
Where regular standard data message rates apply?
Yeah.
Okay, thank you, Zubby, for this educational time.
You're welcome.
This
Bye.
was Space with Zubby 101.